Hi, this is Lori, and this is my homework for Paul McWhorter's Uno R4 course. This is the homework for lesson 33, where we're using a photoresistor. All right, we'll take a quick look at this very simple setup. Paul has suggested a couple things. We could use a servo, and that's what he does in the next lesson, to have the servo move based on the value of the photoresistor. He also mentioned we could maybe take an RGB LED and change the color based on the level of the photoresistor. Thought that was a fun idea. But I just decided to use the LED matrix that we already have here. So my program's actually running. This is supposed to be a sun, in case you didn't know. So that means that's the full light in the room. That's the sun. So there's my photoresistor hooked up. So that's all I have in this circuit. Now, if we take a look at the code, we'll see that my three pictures that I'll show based on the amount of light that the photoresistor is seeing. If it's in the highest light, it'll be a sun. If it's in medium range, it'll be a cloud. And if it's in the lower range, it'll be a moon. Yeah, my pictures are maybe not the best. So I'm a little challenged when it comes to artistic things. So I have my sun picture, I have my cloud picture, and I have a picture of the moon. I struggled with the moon quite a bit. I was able to find something to help me do a cloud, but I didn't find anything that really helped me with the moon, so I did the best I could. All right. So we'll set our photo pin, we'll create a variable to get the value from the photoresistor, and we'll check to see if it needs to be updated. I didn't want it to flicker a lot between values, so I have kind of a range under which it won't change. And then I also want to get the initial light for the room, because even in this office, the light changes as the day goes on. And I didn't want to have to constantly be changing what I'm setting my intervals to. So I found this worked for me. And then I set up an interval to decide on the ranges for the sun, cloud, and moon. And I found 100 seemed to work in this room, but I can imagine in other rooms that you might need to change this interval some. So in void setup, start our matrix, set up our photoresistor, and we'll get our initial reading of the light in the room. Then in the void loop, we'll read the photoresistor, and then we'll determine if we need to update. So it has to be outside of plus or minus 10 in terms of the light that we're getting back from the resistor, or we won't go in here and change, potentially change the picture that's showing on the LED matrix. So if it's the initial value minus 2 times that interval, then we're going to get the moon. If it's only 1 times the interval, we'll get the cloud. And then if it's in the full light or otherwise, we're going to get the sun. And then we'll set old value to photo value, delay a minute, and go back through the loop again. All right, so hopefully this will work. I find that getting the cloud to show up, it can be a little challenging because with your finger or whatever to try to change it. But so that's our full light, and I'll kind of try to create a shadow here on it with my finger, and kind of hold it to the side hopefully. And I've got it pretty close now. There we go. There's the cloud, and then I'll cover it completely. And yeah, there we go. I have to cover it completely here to get the moon. And there's the cloud and full brightness. So I guess there we go, and really cover it. Lit up, there's the cloud and the sun. All right, so that's what I did for this one. I want to thank Paul for the great lesson and telling us exactly how photoresistors worked. I really appreciate that. I really enjoyed that, so I hope he keeps doing that for a lot of these components. I really appreciate the way he explains things that all of us can understand and don't need a PhD in electrical engineering to figure out how a photoresistor works. And I want to thank you for watching.